Alright, now let's actually dive into organic nomenclature. The first thing you need to know is that nomenclature just means naming. So it's the rules that have been assigned by a group called the International Union of Pure and Applied Chemistry, or IUPAC for short. And they're the ones who set all the chemical names. All the stuff that you learned in Science 10 and Chem 20 about naming ionic compounds and molecular compounds and acids, those are all rules assigned by IUPAC. So now we're going to learn the specific rules for naming organic molecules because they don't follow the same rules as the others. So the first thing you need to know is that they follow a general pattern, and that general pattern is number dash branch parent. And so there's always going to be a number that tells us where the branch is, if there is a branch, and then we're going to have to identify what the parent molecule is and know how to name those. I'll try to differentiate these by different colors if I can help it as we go along to help you see how this all makes sense. The first thing you need to understand is how to name the parent. So the parent is always going to be the longest carbon chain that's attached to the functional group. Don't worry about functional groups for today. We'll start into that tomorrow. For today, just the longest carbon chain. So on any molecule, that's what you're going to look for. Doesn't matter if you go up, down, sideways, just follow it around. It has to be one continuous path. What's the longest chain possible I can find? And then to name that parent, we use prefixes to say how many carbons are in that parent molecule. So in your notes, you've got this pattern. There's 1, 2, 3, 4, and then 5, 6, 7, 8, 9, 10. 10's as far as we're going to go in Chem 30, so that's as much as you need to know. 5 through 10 are pretty easy because they're numerical prefixes. So 5 is pent, 6 is hex, 7 is hept, 8 is oct, 9 is non or non, and 10 is dec. So these, at least most of these, are probably ones you're familiar with up to this point. The first 4, though, don't follow numerical rules. So these are ones you're just going to have to memorize. Number 1 is meth, 2 is eth, 3 is prop, and 4 is bute. Now each of these I'll show you how they work here in just a second, but you do need to make sure that you know these prefixes before we jump into how to actually put this together. So make sure that that's something that you memorize. The next one is that the parents that we're going to work with today, the specific type of parent, is called an alkane, which means that all of these prefixes, which tell us how many carbons are in the parent, will end with the parent name, or at least the type of parent that it is, which in this case is an alkane, which means they'll end in A-N. Oh, that's ugly. A-N-E. So for example, meth, let me change colors here just to show this. Methane means it's a 1 carbon molecule in the alkane family. Propane, butane, right? All of these molecules, octane, are made by taking the prefix that tells us how many carbons are in that molecule, and then the ane ending, which tells us that which family or group of organic molecules it's in. So that's what you're going to see in today's lesson, is specifically working with the alkanes. Now, the next thing in your notes is, though, what do we do if we're naming a branch? If you have a 2-carbon branch, for example, that would be a eth, to say that it's a 2-carbon, and branches end in a suffix YL. So ethyl, like this, tells me that that's a 2-carbon branch, because the eth tells me 2 carbons and the YL tells me that it's a branch. If I have more than 1 branch, branches will always get listed in alphabetical order. So if I have an ethyl branch and a methyl branch, for example, I would list the ethyl branch before the methyl branch because those branches come alphabetically. Now, all of our branches will need numbers, so these are both going to get numbers as well, but I'll cover that here in a second. The other thing to note is that sometimes you'll have more than one branch. So let's say I have 3 methyl branches. Well, if that was the case, I would have 3 numbers, and you don't need to worry about the numbers right now, but let's just say it's a 2, 2, 4. And because there are 3 of them, I would have to call it a trimethyl. So this is telling me that there are 3 1-carbon branches, and the locations of those 3 branches are on carbon 2, and carbon 4. So that's kind of the gist of what that is. Hopefully this will all start to make sense when we do some actual examples here in just a second. So that covers branch names, parent names for the alkanes, and multiple branches as well. So now let's jump into the actual steps of what this is going to look like here. Let me pause this for a second. Okay, here's the example that's in your notes, and let's go through this one together. The first thing to always do is to find and name the parent molecule. Remember that the parent molecule is the longest carbon chain. So take a look at this molecule for a second, pause the video if you want to, and see what's the longest possible chain you can make. Again, it doesn't matter if you go up, down, or sideways, but it has to go in a straight line. You can't double back. The longest chain you can make here is 6. And I went this way, so that's our parent. Now there is another way to get 6 here, and that's if you said that this was the parent. The problem is that means that now I have to try to name this as a branch, and that's beyond what you're going to learn in Chem 30. So don't do it that way. First thing I would do is mark in my notes, circle this, that is my parent. Since it is a 6-carbon molecule, the prefix that tells me that it's 6 carbons is hex. So this is a hex. It's an alkane, which I'll teach you what that means here in a second, but it's a hexane parent. Now that means that anything that's not the parent is a branch. So step number 2 is we need to number the parent so that I know where my branches are. Now I can number the branches from either the left side or the right side, but I always want to number it so that the branches get the lowest numbers possible. So for example, if I number this from right to left, I get 1, 2, 3. I'm numbering the carbons. 4, 5, and 6. That means my branches would be on carbon 4 and carbon 5. Okay? If I go the other way, my carbons are 1, 2, 3, 4, 5, 6. And now my branches are on carbon 2 and 3. So since that's the lowest number, that's how I want to number it. My branches will look like this. Now that I know what the branches are, or where they are, this is a 1-carbon branch on carbon 2, so this is a 2-meth because it's 1 carbon, YL because it's a branch, and then this is a 3- because that's where it's attached, 2-carbon branch, so it's an eth, and it's a YL because it's a branch. So now I've named all the pieces, I just need to put them together. So remember that our branches always get number dash branch parent. Branches always come first in the name, and then branches always get listed alphabetically. So I would start with my ethyl branch. This is a 3-ethyl dash 2-methyl hexane. Okay, an important thing to note here, anytime you go between a number and a word, like here, I have to have a dash in between numbers and words. Same with when I went from word to number here and then number to word here. There always has to be a dash there. In between words, like here where I had methyl and hexane, there isn't even a space. That just gets smashed together into one big long methyl hexane combined. If you have multiple numbers, then you have to have commas. So if it was, for example, a 2, 2, 3 trimethyl. So I still have to have the dash between numbers and words, but between the numbers and other numbers, I have to put commas. So that's just a formatting thing to be aware of going forward. So that's the basic setup for how this is all going to work. In the next video, we'll look at the alkane family specifically and a couple more examples.